Section 2.3, an introduction to problem solving. In this section, we look at some of the types of problems we might come across in dealing with linear equations. A general process that we can use for problem solving is to first read the problem carefully and be sure that you understand it. And of course, we might need to read through it more than once to get a clear understanding. Then we have to decide what should we assign our variables for. And sometimes we'll need to write other quantities, other unknowns, in terms of that same variable. Write an equation that relates the quantities described in the problem. And we might need to sketch a diagram or refer to known formulas. Solve the equation. Use the solution to determine the solutions to the original problem. Don't forget to include any necessary units. And a fourth, and sometimes the overlooked step, is to look back and check your solution. And does it seem reasonable? So we just have to be careful. If you're asked for a number of people in a problem and you get a negative number, something's probably not right. So sometimes common sense is very useful in problem solving. Some problems are very straightforward. For example, here are a couple that involve just simple translations and then solving the equation. Twice a number plus 7 equals 9. Well, if we say that this our number, let's call that number our variable x. Twice a number plus 7 equals 9. Twice a number means multiply the number by 2. Plus 7 equals 9. Fairly straightforward. We would subtract the 7 from both sides, yielding 2x equals 2. Dividing by 2, x equals 1. Answer the problem. The number is 1. Why don't you try the other one on your own? Now would be a great time to pause. Three times a number is 18 less than the number. Again, let me call the number x. 3 times a number is 18 less than the number. Now be careful here in this phrase, this 18 less than the number, we know it's a subtraction. But when you see that phrase less than, it switches order. So 18 less than the number would be written as x minus 18. We've got variable terms on both sides. I will subtract x from both sides. So then I have 2x is equal to negative 18. And dividing through by 2. X is negative 9. So the number is negative 9. The sum of 3 consecutive integers is negative 237. Find the integers. Alright, so this phrase, consecutive integers, may be new to you. So we might need to look something up if necessary before we can solve the problem. Hopefully we don't see this the first time on a test. Consecutive integers, consecutive means one after the other. So for example, 7, 8, and 9 are consecutive integers. Now how would we get from one to the next? Well, to get from one to the next, we would add 1. To get from the first to the third number, we would have to add 2. So, if I called the first number x, the next number I would have to add 1 to get to it. That would be x plus 1. To get to the third number from the original, I would have to add 2. So there are 3 consecutive integers, x, x plus 1, and x plus 2. I see the word sum. That means I've got to add. So I need to add up some consecutive integers and get negative 237. So then x plus 1 plus x plus 2 needs to be negative 237. And I put these parentheses here to signify the 3 separate consecutive integers. Combining like terms, x, there's 3 x's, plus 1, plus 2, that would be a plus 3, is negative 237. Subtracting 3 from both sides of the equation, 3x is negative 240. Dividing by 3, x is negative 80. And we're done, right? Well, wait a second. It said find the integers. X only represented the first of the 3. We needed to find all 3. So the integers are negative 80, adding 1, negative 79, and negative 80 plus 2, negative 78. So be careful. The solution to the equation is not always the answer to the problem. After losing 30 pounds, an individual weighs 110 pounds more than 1/3 his previous weight. Find the previous weight of the individual. Alright, well, let's call the previous weight x. Well, now the current weight, well, this person's lost 30 pounds. So if you lose 30 pounds, it's being subtracted from the original weight. So his current weight is x minus 30. But wait a second, it's also 110 pounds more than 1/3 the previous weight. 110 pounds more than 1/3. Alright, so 1/3 the previous weight, 110 pounds more, and these are both his new weight. He's 30 pounds less than the original, and 110 pounds more than 1/3 of the original. So now we equate them and solve the equation. Alright, I've got a fraction here, and I don't want to deal with that fraction, so I'm going to multiply both sides of the equation by 3. And that'll help me clear fractions. 3x minus 90 is equal to x plus, 3 times 1/3 is 1, so 1x. 3 times 110 is 330. Variables on both sides, I'll subtract x from both sides. That'll give me a 2x on the left. Bring the non-variable terms to the right by adding 90. And that gives me 420 on the right. Dividing through by 2, x is 210. So the previous weight was 210 pounds. Let's go ahead and check our work on this one. So if the previous weight was 210, he's lost 30 pounds. So the current weight would be 180, 30 pounds less than. But it also needs to be 110 pounds more than 1/3 of his previous weight. 1/3 of 210 adding 110, that would be 70. 1/3 of 210 is 70. 70 plus 110 is 180. It checks. I'm very confident about my solution. Some of the problems we're going to have to deal with will involve percentages, so it'll be useful to remember how to convert between percentages and fractions and decimals. So for example, 37%, remember, is the same as 37 over 100, which is the same as the decimal number 0.37. 8.1% is the same as 8.1 over 100. Now sometimes we don't like having a decimal in a fraction, so what we do there is we multiply by a power of 10 to make the numerator a whole number, and so that would give us 81 over 1000. Now to get to the decimal number, and I'm sorry I didn't mention this, but to move to the decimal number, to move from a percentage to a decimal number, just bring the decimal 2 places to the left. And so that's where we got the 0.37. And for this one, we would get 0.081. Similarly here, 252% is the same as 252 over 100. Or, as a percentage, as a decimal number, 2.52. Let's do one more here. How would we write 40% as a decimal? This is one that tends to cause problems. 40% would be 0.4. 4% is 0.04. Again, remember, moving the decimal 2 places to the left. Moving the decimal 2 places to the left and bringing in a 0. Those are a couple that tend to cause problems. Let's go in the other direction. Let's say we have a decimal number and we wish to write it as a percentage. Well, if it's already a decimal number, all we need to do is go in the other direction. Move the decimal point 2 places to the right. 0.08 is the same as 8%. 2.97 is the same as 297%. 7 over 20 is a little tougher because it's in a fractional form rather than a decimal form. So what we can do first is change it to decimal form by going through long division. So 20 divides into 7.0 3 times. 5 times. So 7 over 20 is 0.35, which is the same as 35%. So now let's look at a few percent problems. In 2000, about 457,000 people received a master's degree, and by 2005, this number had increased to 506,000. Find the percent change in the number of master's degrees over this time period. When I see a percent change problem, I think that the change is a percentage of the original. So the change is new minus original in this situation. So the new number is 506,000, The original number was 457,000. Is a percentage, hey, that's our unknown, of the original. When you see percentage plus of, that's a multiplication. The original was the 457,000. Going through the subtraction here. Alright, so now that we have the equation, let's go ahead and solve it. We have 506,000 minus 457,000. Let's go through that arithmetic. Alright, the zeros all drop down. And doing some borrowing here. 16 minus 7 is 9. 9 minus 5 is 4. So we have 49,000 on the left. Is x times 457,000. So then so now solving, we would divide through by 457,000. Alright, so let's do that arithmetic. 457,000 into 49,000. Alright, and there's our decimal point. Bring in another 0. 457,000 won't divide into 49,000, but it'll go into 490,000 once. Multiplying back. The zeros all come down. 490 minus 457 would give us 33,000. 457,000 won't go into 33,000. I'm sorry, it won't go into 330,000. So let's bring in another 0. Should go into 330,000. Let's see. 4 times 7 is 28. 4 times 8 is 32. But 45 times 8 is going to be more than 32, so I'm going to think it's 7 here. I realize I made an error here in my division. Sorry about that. No, I didn't. That's correct. 457,000 won't divide into 330,000. But it will go into 3,300,000. It looks like 7 times. 49, carrying a 1, a 4. 35, 39. Carrying the 3. 28, 31. Alright, so that appears to be right. That's good enough for now. We would say that x is approximately 0.107, so about 10.7%. Tuition is currently $125 per credit. There are plans to raise tuition by 8% for the next year. What will the new tuition be per credit? So, new tuition, currently $125 per credit. I'm going to use the same idea from the previous one, that the change is a percentage of the original. We don't know the change in this case, so let me call that the x. The percentage is 8%, which I will write as the decimal, 0.08. The original is 125. So multiplying that out, 125 times 8 is 0, carrying a 4, 0, 16, 20, carrying the 2 is 10. And then let's see, I have two decimal places, so x would equal 10. But now that's the change. So the change will be $10, and it's going to be, they are planning to raise the tuition. So the new tuition would be $125 plus the $10 increase, $135 per credit. Another percentage problem. There are about 13.6 million acres of rural forest land in Wisconsin. This is about 38% of the state's total area. Approximate the total area of Wisconsin in millions of acres. So the forest land, the rural forest land, the forest land is 38% of the total. Now we know this number, the forest land is 13.6, is 0.38 of the total. We don't know the total. Dividing through by 0.38 and going through our division process, we don't like to divide by a decimal number, so I will move the decimal place to the right 2 spaces. Do the same thing here. Bring in a 0, and there's my decimal point. 38 won't divide into 13. It will divide into 136 3 times. And 38 will divide into 220. Looks like 6 times? That would be, too much, so it would have to be 5 times. Let's see, multiplying back, 5 times 38 would be 190. With the remainder of 30, bringing in an additional 0. 38 will divide into 300 6 times. 6, maybe 7 times. Yeah, 7 times. And let's go one more. 38 into 340. Eight times. All right, let's see. That would give us 4, carrying the 6. And that would give us 36, which is too much. Okay, so 35.78. So x is approximately 35.8. So 35.8 million acres. All right, a formula you should probably know now is that distance is equal to rate times time as long as we are given a constant rate. If there's any acceleration, it becomes much more difficult, and we probably wouldn't see those at this level. So use the formula d equals RT to find the value of the missing variable. If the R is 70 miles per hour and T is 2.5 hours, the missing variable would be D, and D would equal 70 times 2.5. So D would equal 175. And what are the units on that? You have miles per hour times hours, then the distance would be miles. And if you sort of think about what miles per hour, we have miles per hour times a number of hours. The hours reduce out, leaving miles. Distance equals 200 miles. Rate equals 40 miles per hour. Then time is missing. So we would have 200 is equal to 40 t dividing through by 40. T equals 5. What are the units on that? Well, time would have to be in terms of hours, since we had miles per hour, 5 hours. A distance problem. A pilot flies a plane at a constant speed for 5 hours and 30 minutes, traveling 715 miles. Find the speed of the plane in miles per hour. Now the speed needs to be in miles per hour, so we got to be careful here. Because look at this time. The time is 5 hours and 30 minutes. Well, we have to get that down to just hours. So remember that 30 minutes is half of an hour. Because remember, there are 60 minutes in an hour. 30 over 60 is 1/2. So time is 5.5 hours. Remember, 0.5 is the same as 1/2. Find the speed of the plane in miles per hour. That's the rate. So, distance equals rate times time. 715 equals R times 5.5, dividing through by the 5.5, going through the long division, moving our decimal appropriately. "55 divides into 71 once. "55 divides into 165 3 times. And that would be exactly we still have that 1 0 before the decimal place. 55 divides into 0 0 times. R equals 130 miles per hour. Two cars pass on a straight highway while traveling in opposite directions. One car is traveling 6 miles per hour faster than the other car. After 0.5 hours, the two cars are 171 miles apart. Find the speed of each car. going to draw a little diagram for this. Alright, so they pass each other at this point. So here's car 1, and here's car 2. They're traveling at different rates. We know that one car is traveling 6 miles per hour faster than the other car. We don't know their rates, but we know that one rate is 6 miles per hour faster than the other. And we're asked to find the speed of each car. So let's call this one x. That rate is x miles per hour. The other rate would be x plus 6 miles per hour. 6 miles per hour faster. We're adding 6 to it. Now we want this total distance to be 171 miles. And after 0.5 hours. So the distance of the first car, let's call this 1, let's call this 2. The distance traveled by the first car would be its rate, x, multiplied by its time, 0.5 hours. The distance traveled by the second car would be its rate, x plus 6, multiplied by its time, 0.5 hours. And we want the total distance to be 171 miles. So we would have the equation x times 0.5 plus x plus 6, times 0.5 is 171. Well, that's the same as 0.5x, distributive property, 0.5x plus 0.5 times 0.5 times 6 is 3, is 171. 0.5x plus 0.5x is x, and x plus 3 is 171. Subtracting 3 from both sides, we have x is 168. Now, what is that telling us? The rate of the first car is 168 miles per hour. The rate of the second car is 174 miles per hour. That sounds like some of the people I see on I-4 on a regular basis. But now, it doesn't seem reasonable, but let's just see what happens here. So after a half an hour, so this first rate, after a half an hour, this person would have traveled 84 miles. And the other person would have traveled 174, divide that by 2, would be 87 miles. And those do add up to 171. So, it doesn't seem reasonable. Most cars aren't going to be traveling at 168 miles per hour. Unfortunately, this might have been a poorly stated problem, but we have solved it correctly. All right, that does it. Have a good day.